All right, so this is the longer video that I will be doing analyzing tomorrow's severe weather threat. So we're going to start on the SPC mesoscale analysis page. Now, this is the page I'm going to use for some of the stuff later, but just to start off, you can see the low pressure system in the center of the country right there, producing some thunderstorms over a broad area. You can see the line there with some storms out in front as well, trying to form maybe some supercells. It's actually a pretty large area that is being affected right now. Um, Overall, it's a very large risk, and the risk is fairly high for this area, although our risk tomorrow is actually, in fact, higher, and we'll get into that right now. So, at least in terms of level, we are on the same level as the risk area that's been seen in the central part of the country today. We are level 3 out of 5 enhanced risk. These risks are made by the Storm Prediction Center, and they're basically denoting how much of a risk you're in for severe thunderstorms over the course of a day. So for Monday, we're in a level 3 out of 5 now, but there is a level 4 out of 5 to our south. Level 4 out of 5 is very rare for this area. I just don't remember seeing it that often. There was one instance, August 7th, 2023. There was a level 4 out of 5 that got into parts of Lancaster County. Chester County was in a level 3 out of 5, and then areas further east were also in a level 3 out of 5. That ended up being a pretty substantial day for the general area. There was a fair amount of tornadoes to the south, and west, and there was also some damaging winds, especially through the area along the Mason-Dixon line. With this event, it's expected to be widespread as well, maybe even a little bit worse than that in terms of how widespread it will actually be. So you can see this is a graphic made by the National Weather Service at Mount Holly. Severe thunderstorms are likely. Primary hazard is damaging winds, though a few tornadoes will be possible. And again, for when you're going further south and west, that is where the more tornadic threat lies. For us, damaging winds are going to be the main threat. So the risk is for the entire area. Yes, it's for the entire area, but there is one caveat to that. Once you start to move further and further to the east, say get past the Delaware River, it will get more stable, meaning you'll have less chance of severe storms because as you get closer to the Atlantic Ocean, the air there is cooler because of the ocean influence. So the winds are going to be out of the southeast during this event. So when you get winds out of the southeast coming off the Atlantic, that's stable air that's not really going to cause any disruptions in the atmosphere. So your severe weather chances will be more limited, though they are not 0%. You are still in a level 2 out of 5 for a large part of New Jersey and level 1 out of 5 up through New York. So with this event, you really have to monitor the latest forecasts, as it says here, and then make sure you can receive watches and warnings. Make sure you also have a plan in place in case stuff goes down. So there could be significant weather, gusts of at least 75 miles per hour, hail of at least 2 inches. Probably not with this event. That's just with the term significant. I do think gusts of at least 75 miles per hour and a tornado or two of at least EF2 plus. Yes, I think with this event that is also possible. We'll get more into that right now. So this is the Storm Prediction Center's actual outlook on a wide scale. I'll go through each categories here. You can see there's tornado, wind, and hail. So we'll start with tornado. Tornado. This is where it gets a little complicated, and I'll try to explain it best I can. The Storm Prediction Center has probabilities of a tornado. These are within a 25-mile radius. So what you're actually looking at is probability within 25 miles of a certain area of seeing a tornado. And you can see that the intensities go up as you go up the list. So in Chester County, it's actually split. It's about a 5% down the line and then a 2% on the eastern side. Philadelphia is in a 2%. And then again, going further west and south, you see that 10%, and you also see that 15%. But you also might notice this intensity graphic with the hatching. That is known as the SIG colors. So the SIG colors denote what is the maximum probable tornado in terms of intensity. So how high can that intensity get in this sort of setup? And what that SIG1 generally means is that your maximum intensity is going to be around EF2. You're not going to get much higher than that. If it was shaded in the intensity 2 color, it would be EF3. And then if it was shaded in the intensity 3, it would be EF4. For this event, it's a large area that the maximum intensity expected is about EF2, which again, don't sleep on an EF2 tornado or an EF1 or an EF0. Anything of that magnitude will cause damage. So there's no reason to look and say, oh, maximum intensity EF2, I don't have to worry about this event. This could still be a very widespread and big event, especially with the other factor, damaging winds. Now, you can see this noted here with the intensities. These are a lot higher than tornadic intensities. You can tell right off the bat. There's a large 45% risk for a lot of Pennsylvania, a lot of areas to the south, parts of the Carolinas, parts of Virginia, parts of Maryland, parts of Delaware, even parts of New Jersey. There is a large 30% risk that's outside of that. And most importantly, there is a 60% risk of damaging winds within a 25-mile area in this region here. It extends up to about the Mason-Dixon line in central PA. Oops, let me get back to that. Up to about this Mason-Dixon line, as I previously said, and then down into central South Carolina. And then you can also see there's hatching here. That's for the intensity of wind as well. Again, that's noting that there could be the maximum expected intensity of the wind is probably about 75-ish miles per hour. This may get increased later, just depending on some other factors we're going to go through right now. So we'll be going back to the mesoscale analysis page just to take a look at what is known as CAPE. So CAPE is a short term for convective available potential energy. That is a term that you will understand if you take physics or know anything really about physics. So it's the potential energy for convective system, thunderstorms. It's the potential energy that they can use in the air. It's measured in joules per kilogram. So it's a measurement of how much actual energy there is in the air that can be converted to kinetic energy in thunderstorms. What you really want to see for a lot of the big storm events is upwards of 1,000 joules per kilogram. But for this event, it's different because of something known as the 500 millibar jet. That's what can be seen here. This is an extremely strong 500 millibar jet. So what the 500 millibar jet does is it creates spin. It creates wind shear in the atmosphere if you have wind going in different directions. In this event, we do. So that wind shear actually causes tornadoes because it's moving in different directions. You're causing spin to be generated. And wherever that spin is generated, you can get tornadoes to happen. And here, because that 500 millibar jet and wind shear is so strong, you really don't need that much CAPE in this event to get storms going or even tornadoes. Because the shear is so strong, it'll be generating them often pretty quickly. But any added energy obviously will only help to increase that threat. So if you do see some clearing during the day, and this 500 millibar with this 500 millibar jet in place, you're going to see some big stuff go down. So now we're going to get into some of the model outlooks. We'll start with the HRRR. The HRRR, I like it. Usually does pretty well with some of the simulated radar stuff. So we'll start by looking at the CAPE, as I mentioned. So that we're looking at surface-based CAPE, and then there's also going to be something known as photographs on here. Photographs is basically what are the winds doing with height in the atmosphere. So it's looking at how it's going to change as you go higher up in the atmosphere. You can see that curvature there. That is exactly what you want if you want to see tornadoes. Now, if you don't want to see tornadoes, that's not what you want to see. You don't want to see a curve like that because that means that there's a lot of changing motion in the atmosphere. The winds are changing with height, and you're going to have spin. Well, we have plenty of spin here, as you can see with those photographs. So as we move into the day, you can also see, get that energy up. It's not that much around the Chester County area, only about like 800 joules per kilogram, 700 in some areas. And then out and further in central PA, though, it is up to 1,400 joules per kilogram. But again, in this event, you do not need that much CAPE. You already have plenty of the 500 millibar jet moving through, so you really don't need that much CAPE to generate that spin. So now we'll move to the SIGTOR, which is the significant tornado per area. You can see some of it around 1 here. This tool is good for looking at, how intense your tornadoes can get, how probable they are in some areas. Now what I'll be doing is taking what is known as a model sounding. So basically, I'm looking at the actual, if I put a weather balloon in the exact area where I'm taking this sounding, it would basically be looking like the sounding does. It's a future reflection of that. So you're basically looking up into the atmosphere on this, and you're seeing how everything's changing. So here you can see going up into the atmosphere. You can see our millibar layers here. I did this in one of my winter forecasts. So you can see your millibar layers here. You can also see, whoops, let me go back to that real quick. You can see your millibar layers here. You can also see your temperature here, your dew point here, and how it changes with height. You can see your temperatures in Celsius on the bottom. And then here's your hodograph. That's the main thing we're looking at here. You can see your possible hazard type. It also tells you your surface-based CAPE values here, and then your mixed layer here. The mixed layer is important because an elevated mixed layer, which is what it is known as, can actually help to cap thunderstorms for a time being. And you might be saying, well, what does that mean? What it means is it can put what is called a cap because it's putting a cap on the amount of rising motion that's possible in the atmosphere. And if you cap that rising motion in the atmosphere, you're going to prevent early morning convection. And what early morning convection might do is it might actually cause there to be less energy available in the atmosphere because it can get zapped out by early morning convection. You prevent that from happening in the first place, you have a higher likelihood of seeing big stuff go down in the afternoon because there's more energy that's been left from the morning to take advantage of. And you can see that on the HRRR here. It's mostly clear, besides those few morning showers. It's mostly clear at 11 a.m., 12 p.m. There's some showers around, but again, they're much more isolated than widespread. Then you get into the afternoon, then you start seeing stuff goes down. You see some actual cells get in here. And then obviously you can see that squall line actually looks like a couple of supercells here instead of a defined squall line. It's not really the squall line itself. It's more like supercells up and down the line. That's a pretty concerning look, not something you really want to be seeing. And as you move it along here, you can see the squall line comes in. That is an intense bowing segment. If you got something like that, you would see winds of 75-ish miles per hour, maybe even more along that line. That would be a very destructive line, maybe even some spin-up tornadoes in there. And then you can see the system moves out. We actually might see some snow at the very end of that. Now I want to use one more tool that I like to use. So this right here, it's called updraft helicity, and it's the run max of that. So what the updraft helicity is, it's basically a measure of how much spin has happened over the course of the entire model, the HRRR. So you can see just some streaks along here. That means that there's been spin in those storms. That means that a lot of those storms, even the squall line ones, do have spin in them, and they might produce tornadoes. We can do the same with various other models. We can look at the NAM3K. Now, I believe NAM3K doesn't have it to much degree. Yeah, no, it doesn't. So you can see the NAM3K mainly has stuff out in Central PA, but not much in Southeast PA, not much in the DC area. I don't really buy this solution, mostly because of the parameters in place. I already described that the 500 millibar jet, we can check that out here, is very strong. So again, I mean, you can just see this. So again, this is higher up in the atmosphere, many thousands of feet up. But when you see a 500 millibar jet and it's got winds of about 90 knots on it, that's trouble. That certainly means something. And even when it's kicking through the backs, you can see those winds get really intense. And that indicates to me that off the back end of the storm, you could have some damaging winds as well. Even once the actual storms themselves are through, you could have some very strong wind gusts after the fact, after the storm's kicking through on the back end side when it's not even draining or doing anything outside. We'll look at one more model really quick. It's known as the RRFSA. This is a new model. It's been in production, but I found it does pretty good on some of these events. So again, you can see that 500 millibar jet absolutely ripping. Looks insane in the higher levels. So move back here and look at some of the storm modes. You can see it's mostly cleared out during the day. Temperature-wise, check that. Actually getting us up into the 70s. If you're getting up into the 70s with this event, you mean trouble. That means that it's probably going to be sunny. That means that there's going to be plenty of available energy in the atmosphere. If you don't want to see bad storms, you do not want to see sun tomorrow. If you're looking at sun, then you're in danger. So we'll also look at the cloud cover real quick. I want to get a metric of how much clouds there are. You can see it's pretty covered at that point, but there's some clearing that tries to get through. certainly will be something to watch to see if you can get more clearing than what it shows. We'll get down to looking at some of the updraft velocities here. So we'll be looking again at how much spin there is in the atmosphere. You can see as that squall line moves through, all the supercells down in DC during all that spin. You see that move through here. And there would certainly be damaging winds again up and down that entire line, which is really my concern here. But again, spin up tornadoes, you can see some of those updraft velocities right there. I think there could be some spin ups as well. Definitely somewhat concerning there. And again, keep an eye on all of this. I think if you have more clearing, you're certainly going to see this risk get upgraded from the SPC in later time frames. Especially, we'll see what it's like tomorrow morning. They might do an update tomorrow afternoon as well if things are looking really impressive on all the vectors and everything like that. I'll keep posting updates on Instagram, but as for this video, should be about it. Again, I'll let you know what's going to happen on future posts, future story updates, everything like that. Thanks for joining. If you got any questions about anything I mentioned in this video, please reach out, please ask. I love to teach people about this stuff. It is my hobby, it is my passion. So let me know if you got anything. Thanks for joining me.